If you've been watching closely, you may spot me cheating. Yes, I did cut some corners, but I did it on purpose. Look at the NPC radius declaration. It's sitting right there in the class, but whose radius is it? Is it guard radius, maybe Questgiver, or boss? And the answer will change how you design every class from here on. Hello. Let's make this question visual and draw the circle around the NPC. To do this, I will implement debug radius circle method in the NPC class. I will use standard pygame circle drawing method. To properly center the circle, we have to know the NPC center point. Luckily, we already have this implemented. Then point to the functions. Now let's run the game and we will clearly see that the radius is equal for all the NPCs. Nothing new, just inheritance doing its job. But what if our character is Sneaky Peeky Chief? How can we cut the spot radius in half on demand? You can iterate through all the NPCs, setting radius directly, and it will work. But also, you can simply set the value for the whole class, and all the instances of the class, including all subclasses, will use this updated value automatically. This is a power in the curse of the class properties. They are set for all the instances of the class. But let's say our sneaky peeky logic should not be applied to the Questgiver NPC. You can set the radius for specific object overriding class property value. Or you can override property for entire Questgiver class. Or you can set object property in the init method. The real problem is to know which exact property is in use at runtime. Python looks for properties in order. Object own property first, then its class, then parent classes up the chain. So when you assess the radius property, Python asks, does this object have this property? No, maybe class, still no, check the parent class. So, things to remember. Object properties are the object own properties and may be different from object to object. Class properties are the properties that are shared across all the instances. Now that we know how Python resolves properties, let's apply the same design thinking we use for the objects. You may recall that I said that changing properties directly from the client code is a bad design. It is. As an object has its own methods, class can have methods too. Let's implement an NPC class method that will cut the spotting radius in half. Class method definition is a bit different from an object method. First of all, we have to explicitly specify that this is the class method using class method decorator. Then, since this is a class method, there is no way to pass self-argument, as there are no objects involved. So we specify CLS as the method first argument. It will be the class itself. Then let's call this method somewhere outside the game loop. As it was with the object method, you don't have to specify the first parameter to the method, as Python will do it automatically. We call this method outside the loop because otherwise we'll infinitely decrease spot radius in the half, making guards blind, not chill. Let's check the game. Looks like everything is working as intended. So classes are more than just blueprints. They can carry state and behavior of their own. Class properties and methods can be used to create utility classes, which will contain some similar functionality. For example, look at our geometry functions: getRectangleCenter and getDistance between points. We can match them into the geometryUtils class. But these functions are stateless, meaning we don't need to create objects to keep state, also we don't have any class level properties. So we don't need to pass nor the self nor this class param. There is another type of class method, static methods. Static method is just a function that semantically belongs to some class. And don't forget to update the client code. Right now, this is mostly about organization, keeping related functions together. Organizing code is important, but imagine you constantly calculating distance between two static points. Instead of spending CPU time calculating distance every time, you can use class properties that will contain already calculated distances, and you can simply look up distance in the list. This is kind of optimization that can save ton of CPU time. And all you have to do is to change static method to the class method, and you don't even have to change the client code at all. But it's a story for another time. Today, we learned that classes are not just blueprints. They can hold own state and behavior. And now you have the full picture: static methods, class methods, object methods, each with its own purpose and each with its own place. Next time we are stepping out of the single file for the first time: modules and packages. Your code is growing and it's time to organize it properly. If you like this video, give it a like, subscribe to the channel, and see you next time. Ciao!